So we're in the middle of Unit 5 of Computer Science A, and we've been writing classes. And so we've been writing methods that can, change classes, and also we've been getting things from these classes, or rather the objects that we're creating from them. And so there's kind of like one-off thing that we have to discuss here about these objects once we create them, and then how they can be changed and how they can potentially be modified depending on what they have inside them. So I'm going to make a very just kind of contrived example here, and so this is not like a real world example by any means. It's going to be totally made up, but it's going to demonstrate a point for us. So what I've done is I've created a thing class. So this thing class is just going to, well, make thing objects for me. So it's going to be public. The class is going to be thing. And then inside of it, all I'm going to hold is, let's just say that I've got a private integer, which is going to be its ID. And then let's go even more basic than that. A is going to be equal to 0 as a starting value. It's also going to have a, I don't think we'll use this, but a string just in case. String B, and it equals empty string. We are going to create a constructor for this, and so it's going to be public, and then public, and then thing. It's going to take in an integer value for A, and then a string value for B, and then update these two values. So then this will be, let's see, so this dot A will be equal to A, and this dot B will be equal to B. Okay. Yep, I think that's what I want to do. We're going to do something that I would probably never suggest doing. I'm going to change these both to public. The reason I'm doing that is just to save myself a little bit of time here. I don't want to have to write getter and setter methods for both of these. And so I'm just creating, or I'm just setting A and B to be public now so that I can both make changes to them and see what they are once I want to go use this class later. So that's going to be one thing I'm going to create. I'm also going to make another new file. This is going to be, it's going to be called set of things.java. And what it's going to hold in here is a thing and then also another number. So public, and then this is called their public class, and then set of things. And like I said, this is totally contrived, and so it's not going to make sense until kind of like the big reveal at the end. So just give me a minute to get there. I'm going to have inside this set of things class two things again. I'm going to have a thing, and this will be, I'll call this, let's call it a different letter, let's call it X, which is nothing, right? And then another integer value, and we'll call this Y. And then we'll have a constructor set of things. So my set of things really just has one thing and an integer in it. And what it's going to do is take in, let's see, another thing, and then an integer Y, and we'll assign both these things. So this dot X equals X, and this dot Y equals Y. Okay, so like I said, contrived example, what's going on here is that I have my thing class. Inside my thing class is an integer value and a string. I have a constructor that gives both those values. That's great. And I have my set of things, which just contains a thing within it, and then an integer as well. So my set of things has a thing, contains a thing object with inside of it, and then another integer. So let's go ahead then and write a new, oh geez, what am I doing? We'll just call this thing tester. Make a new file to test what's going on here. So public class thing tester. I feel like I probably have done something wrong with the other ones, but we're going to figure it out all at once. So public static void main string array, and then args. Okay. So let's just go ahead and make sure that all these things work the way that I want to. So I'm going to make a new thing. I'll call it thing1, and it's going to be equal to new, and then thing, and then it's going to take in, what did it take in? It took in the integer first and then a string? Yeah. So it's going to take in 5, and then And then since I left those attributes private, what I should be able to do is print both of them out. So I should be able to do thing1 dot, and then what was it called? Just A? And then system dot out dot print line, and then thing1 dot B. All right, now if I was smart, I would have already queued up my command line, but I have not. That's okay. Actually, I was in the right spot. Okay, and then desktop, and then computer science A, and now we are in unit 5. All right, I'm realizing I'm doing this all off screen. Here it is. Java compile, and then thing tester dot Java. I'm absolutely shocked that actually worked. But I shouldn't be, right? Of course all my code works. All right, so I printed out the 2 attributes, which is fantastic. Now, let's take this a step further and make something of set of things. So I'm gonna make a new set of thing as object. So this would be called set of things, and this would be set of things 1 equals new, and then what did set of things take in? It took in a thing, which in this case would be thing1, we'll give it, and then we'll give it a new, what was it, an integer? 10, we'll go with. Okay, now, okay, so let's think about what happens here if we try to do some printing. So if I system.out.print line, so set of things 1 should have 2 things in it. It should have my thing and then my number. So let's just go ahead and do the easy one. Let's get my number, which I believe we called y. And then system.out.print line, the not so easy one, set of things .x, and see what happens here. So I print these things out. If you stop and think about what's going to happen here, what should happen. All right, so these are my first 2 print statements for my thing. I printed out 10 because that was the number I stored in set of things. And then I got this, which if you remember, what this is since it's an object, it's printing out. I did not written the toString method, so it's printing out essentially the address, the hashed address of my thing object. So if I wanted to get those actual values in there, I would have to go with .a, and then we could do this again. Let's go ahead and get rid of these. Oh, that's not what I want. Control Z. Better. Okay, so what I should be printing out then is 10, and then this should give me, I forgot, 5, and then hello, I think. Let's find out. Okay, so everything works, fantastic. I have my set of things now, which contains a thing and then also number 10. Now here's the interesting part. So my question to you is this. So this is everything I have about set of things 1. Let's do something a little bit differently. So I'm going to create a new integer value, and I'm going to call it, what do we not use? Z, just to not confuse ourselves, and it's going to be 10. All right, and so instead of actually throwing 10 in here, I'm going to throw Z in here. Okay. And I'm going to save this, and then I'm going to run this, or compile and run it again, and nothing happened. I get the exact same printout, which is great. Fantastic. Okay. Here's my question. If I change Z's value to be 20, should that have an impact on what is printed here? So I'm going to copy the, obviously it's not going to impact, it happens after effect. But if I print them again, does this change anything? Because what we'll note here is that Z was passed in, not 10, but actually Z was passed in as a parameter into my constructor for my set of things class. So let's go ahead and copy this just so we have a nice little break. All right, so I don't know what I just did there. So now the question is, should I get the same thing both times? And so think to yourself for a second, should I get the same things both sides? I changed what Z was. I changed what the value of Z was that was being used here. All right, so if I run this, no change. And we know this to be true. Like we've done this before, right? Where if we pass in this value of z here, it's the value's getting passed. Z is not actually getting passed in. Nothing's actually happening at z here. So now the question is, so let's change this slightly. Let's not just change z, but let's change thing1 dot b. No, sorry. Let's go with thing1 dot. We'll change a. It used to be 5, and now I want to change it to 100. Okay. Should that change anything? And so by the same logic, obviously, it probably shouldn't, right? I mean, that doesn't make any sense why that would. Let's go ahead and run it. And, but it does. Okay, so let's take a note here. Changing z's value from 10 to 20 did not actually change the integer value that was being held there. But if I change the value of a within thing, it goes from 5 to 100. It actually changes that value. Why would that be changed, but not the other? That's a great question. What we're going to have to do is we're going to have to go and flip to, I haven't done this in a while. Let's take that away, and let's go back to our drawing space. So we haven't looked at this in a while. We've had a nice little break from looking at where things are actually being stored on the computer. But we're going to take a look at that now. So let's remind ourselves about what we were just doing. So if you remember, what we had was the first thing we did was we created a new thing object. So if you guys remember how things are stored, I have my stack, which is like the current stuff that's being dealt with, and then I also have my heap, which is just kind of like this mess of memory over here for additional things. So if you remember what happened here, first thing I did was I created a new thing object. It was called thing1. And if you remember what happens with things is that, or objects in general, is that things, I don't know how big my object is, so it doesn't get stored on the stack. What actually gets stored on the stack is my memory address. And so whenever I create a new thing object, I have my constructor, and it gets put over here. And then what that constructor does is it allocates a new portion of memory over in the heap. Because again, I don't know how much actual memory to allocate over here into the stack for my objects. I just don't. All my other primitive values, I know exactly how much I had to set aside. I don't, though, for objects. And so what gets put over here in this case was I have my A value, which was 5, and then my B value, which was hello. Okay. Then what I did was I created my value for z. It was equal to 10, and that actually gets stored on the stack because that's just an integer. And then we create a new thing, which was set of things 1. And so this is another object. So how does this object get stored on my stack? And the answer is that it gets stored as a memory address again. So I have a new memory address. So I'll put it right here. And so this is set of things 1. And I should say, by the way, this points. And now this will point. And what gets put in here? Well, I have two things. I have my x value, my y value. My y value was an integer, which got the value z. And so this is what we call pass by value. In that constructor, when we passed in the maybe I should flip back here for a second. Give me back my computer science space, please. Oh, it's behind. It's okay. So whenever I passed in the z value, it gets passed by value. Whenever I'm giving it a value that's on the stack, the value actually gets put into the constructor. So not z, not the variable z, but what's in z spot, which is 10. And so then when I pass in thing, though, what actually gets passed in, well, what's on the stack? What's on the stack is the memory address. So, okay, if I was better at this, let's go faster. What gets passed in is this memory address. So what the x value gets is, and I might have these flip-flopped, the y value was my number, I think, so it actually gets the value of 10. But what my x value then holds on to is this memory address. It actually gets passed this memory address. We call this pass by reference because the value actually isn't getting placed in there. The reference to the value is. So here's what happens is in the next line of code where I change something about thing one. If I change something about thing one, okay, if I change something about thing one and I update its value here to, in this case, to be 100, well, where is this still pointing? It's still pointing here. So if an object contains another object, and that object is being stored inside the other one gets changed elsewhere in the program, like they're referencing the same things. Because in this case right now, I have two things that are both referencing this memory address, my thing one and the x value inside of my set of things object. Since they're both pointing at the same thing, both of them will change the actual values that are stored inside of my thing object. So this is what's called pass by reference. I always have to be careful about what's actually being stored on the stack. If the thing that's being stored on the stack is a primitive value, then that is the actual value that will get passed into a constructor or a method or whatever it is, the actual value will be get passed in. If the thing that's on the stack is a memory address, the thing that will actually get passed into my constructor or into my method, whatever it is, will be a memory address. And so I can have multiple things that are referencing the same object, and thus they will all change each other in this case. So in this case, right now, if I go back to my computer science space, when I'm referencing what is x dot a, that is the same thing that thing one is pointing at, because whenever I call this constructor on it, this got passed by reference instead. So this is the big idea, the difference between pass by value and pass by reference. It's something that we'll get into more depth into later, but it's just something that's worth noting that I have to be careful about whenever I have objects that are taking in other objects as a value, or actually not just when an object is an attribute for another object, but whenever I have a method or a constructor that takes in an object, there's potential for me to actually change the values inside there then. So I just have to be careful about all those things. So that's the difference between pass by value and pass by reference. It's not a topic unto itself in Unit 5, but it's definitely something that's worth knowing and will be useful moving forward.